Hello everybody, welcome into another lesson. So today is going to be the last lesson on solving systems of equations. And this is going to combine multiplication and division with the addition and subtraction method. Now, if once we get to Algebra 2, there are other methods for solving, such as matrices, determinants, Cramer's rule, but that's not till Algebra 2. Algebra 1, we're going to focus on this method here. So we have here this system of equations. We got 3c minus 8d equals 7. Then we have c plus 2d equals negative 7. Well, what we notice right away is that on the variables, none of the coefficients are the same. But we can make at least one of the coefficients the same by doing multiplication. So what I mean by that, like let's say we have 3c here and just c. If we multiplied the second equation by 3, you would get a 3c. Or your other choice is to take the second equation, multiply it by 4, you would end up getting an 8d. Either way, it doesn't matter. As long as you can ultimately eliminate one of the variables temporarily, that's all that matters. As for me, I'm going to pick the smaller number. I always find the smaller number easier to work with. So what I would do personally, take your second equation, multiply it by 3, then what you'll have is still your first equation, 3c minus 8d equals 7, right? But what you have next, you multiply the second equation by 3. 3 times c is 3c, plus 3 times 2d, that'd be plus 6d. That would equal then 3 times negative 7, that would equal negative 21. So now you still have 3c minus 8d equals 7 and 3c plus 6d equals negative 21. Well, now with the c's, we at least have one variable with the same coefficient. That means if we subtract 3c from 3c, we can temporarily eliminate the c's. So now that we've done the multiplication and figured out the new equation, let's subtract the second equation from the first. So what you'll get here, 3c minus 3c, that's 0, but you get negative 8d minus 6d, that'll give you negative 14d. That'll be equal to 7 minus negative 21, which turns into 7 plus 21, which would give you 28. So you're left with negative 14d equals positive 28, which means d would equal negative 2. So you found the d coordinate of the solution. Now we just got to find the c coordinate, and that's done just by taking your d coordinate and sticking it into one of the original equations. We'll go with a 3c minus 8d equals 7. So you'll have 3c minus 8 times negative 2 equals 7, which would mean you would get 3c minus 8 times negative 2. That's going to be plus 16. That'd be equal to 7, which means 3c would equal negative 9, which means c would equal negative 3. So the c coordinate for the solution is negative 3, the d coordinate's negative 2. Therefore, the ordered pair that would be your solution would be negative 3, negative 2. So negative 3, negative 2 would be your solution to this system of equations. And I got plenty more where that came from. Alright, let's see what's next on the agenda here. we got 3a plus b equals 4. Then we have a minus 2b equals 6. So again, we have another system of equations here where none of the coefficients on the variables are the same. But we got two options here. You can either multiply the second equation by 3 and you'll get a 3a and be able to temporarily eliminate the a, or you can multiply the first equation by 2 and you'll get a 2b and be able to temporarily eliminate the b. I don't know about you, I prefer to pick the smaller number. So I'm going to multiply the first equation by 2. So if we do that, 2 times 3a, that would give you 6a. Plus 2 times b, well, that'll simply give you 2b. That'll be equal to 2 times 4, which is 8. Then you still have a minus 2b equals 6. Now, we notice the b's have the same coefficient, one positive, one negative, so all we have to do is add the second equation to the first, and we can temporarily eliminate the b variable. So 6a plus 6a plus a is 7a, 2b minus 2b is 0, but 8 plus 6 is 14. So you have 7a equals 14, which would just give you a equals 2. So the a coordinate for the solution is going to be 2. Now we found the a coordinate, we need to find the b coordinate. So what we have to do is pick one of these equations to stick the a in and then solve for b. I'm going to pick a minus 2b equals 6. So we'll put in 2 minus 2b equals 6, which means that negative 2b equals 4, which means that b equals negative 2. So the b coordinate for the solution is negative 2. So in the end, the ordered pair you should get for your solution would be 2, negative 2. That would be the solution for the ordered pair, would be 2, negative 2. Alright, let's see. We have x plus y equals 7. Then we have 3x minus 2y is equal to 11. So we have another system of equations here. We have x plus y equals 7, and then 3x minus 2y equals 11. Well, again, we have a system where none of the coefficients on the variables are the same. So we have two options here. We can multiply the first equation by 3 and we can get 3x on the first equation, temporarily eliminate x. Or we can multiply the first equation by 2 and then get 2y on the first equation, temporarily eliminate the y variable. Again, if I were you, I would go with the smallest number. So go ahead and multiply your first equation by 2. When you do that, 2 times x, that'll give you 2x, plus 2 times y will give you 2y. That'll be equal to 2 times 7, which is 14. Then you're still left with 3x minus 2y equals 11. Now, for the y's, we have a positive 2y and a negative 2y, so that tells us all we got to do is add the second equation to the first, and you can temporarily eliminate the y variable. So 2x plus 3x, that'll give you 5x. 2y minus 2y is 0. That's equal to 14 plus 11, which is 25. So you got 5x equals 25, which means x equals 5. So the x-coordinate of the solution is going to be 5. Well, that's great. We have the x. What about the y? We need to solve for y. So you could stick this into one of your original equations. I'm going to stick this into 3x minus 2y equals 11. So we'll go with 3 times 5 minus 2y equals 11, which means 15 minus 2y equals 11, which means that negative 2y is equal to negative 4, which means that y is equal to positive 2. So the y coordinate of the solution is going to be 2. So the solution, that your ordered pair that's the solution, is going to be 5, 2. And that would be the answer for this system of equations. You would get the ordered pair 5, 2. All right. We got 4x plus 5t is equal to 22. And then we get 5x minus t equals 13. So again, we have a system of equations where none of the variables are the same. So how this is going to work is we can try to eliminate the x variable, but that means you got to multiply the first equation by 5, the second equation by 4 to get both coefficients to be 20. Or you can simply multiply the second equation by 5 and you'll have a 5t in the second equation. You could temporarily eliminate the t variable. I don't know about you, I'm thinking we multiply that second equation by 5. So let's go ahead and do just that. So you'll still have 4x plus 5t equals 22. But 5 times 5x, that's 25x. Then 5 times negative t, that's minus 5t. That would equal 5 times 13, which is 65. Well, we have a 5t and a negative 5t, so we could add the second equation to the first and temporarily cancel out the t variable. So 4x plus 25x, that's 29x. 5t minus 5t is 0. You just get is equal to 22 plus 65, that's 87. So 29x equals 87, which means x equals 3. So you get x equals 3. 3 is the coordinate of your x value of the solution. Now we need to get the t value. So you just take your x, stick it into one of those equations. I'm going to go with 4x plus 5t equals 22. Let me write in red for that. So we'll take 4 times 3 plus 5t would equal 22, which means you would get 12 plus 5t is equal to 22, which means 5t would equal 10, which simply means t equals 2. So the t value of the solution is going to be 2. So going in alphabetical order, since t comes before x, you'll get the ordered pair 2, 3 as your solution. The ordered pair 2, 3 is therefore your solution. Now x and t together, this isn't till Algebra 2 and pre-calc going to get into something called parametric equations. Usually it involves t for time and with position with respect to time, but that's a whole nother topic for another time. All right. So let's see, we have 2n plus 5a equals 14. Then we got 6n plus 7a equals 10. So we have 2n plus 5a equals 14, and then 6n plus 7a equals 10. Again, none of the coefficients are the same, so we got to figure that out. Now, if you want to make your a coefficient the same to try to eliminate it, you'll have to multiply the first equation by 7 and then the second equation by 5, and then you'll get 35a for both. I don't think you want to do that. Wouldn't it just be much easier to take the first equation, multiply it by 3, and then you get 6n in the first equation, and then you can eliminate n temporarily? So let's do that. We'll take 3 times the first equation, which if we do that, 3 times 2n is in fact 6n, plus 3 times 5a, that would give you 15a. That'd be equal to 3 times 14, which is 42. So you get 6n plus 15a equals 42. Then you still have 6n plus 7a equals 10. Now, the n coefficients are the same. We can go ahead and subtract the second equation from the first. So if we do that, 6n minus 6n is 0. 15a minus 7a, that's 8a. And then that's going to be equal to 42 minus 10, that's 32. So you're left with 8a equals 32, which would give you a equals 4. So the a value for the coordinate of the solution is going to be 4. Now we need to find the n value. So just take your a value, put it into one of the equations, and you'll get your answer for n. I'm going to go with 6n plus 7a equals 10. So that's going to give me 6n plus 7 times 4 equals 10, which means I'll get 6n plus 28 equals 10, which means 6n equals negative 18, which means that n equals negative 3. So the n value for the value of n for the ordered pair is going to be negative 3. So again, we go in alphabetical order, a then n. So your ordered pair, that's the solution, is going to be 4, negative 3. That would be your answer, is going to be 4, negative 3 for your solution. Just because the equation appears out of order, which it will sometimes, the variables will be out of order in the equation, when you go to list the solution, it always goes in alphabetical order. So keep that in mind. Alright, what's next? 3p plus 4q equals 4. Then we have 5p plus 2q. That's going to be equal to 16. So we got 3p plus 4q equals 4. Then we have 5p plus 2q equals 16. I think it's obvious that we would like to multiply the second equation by 2 to get another 4q so we can temporarily eliminate q. So let's go ahead and multiply that second equation by 2. So what you're going to have here, you still have your 3p plus 4q. That's equal to 4. But then 2 times 5p, that's 10p. Plus 2 times 2q, that's 4q. That's going to be equal to 2 times 16, which is 32. So you have 3p plus 4q equals 4. Then you have 10p plus 4q equals 32. Well, now the q's have the same coefficient, so we could subtract the second equation from the first, and we can temporarily eliminate q. So 3p minus 10p, that's going to be negative 7p. 4q minus 4q is 0. So negative 7p is going to equal 4 minus 32. Well, that'd be negative 28. So we get negative 7p equals negative 28, which means p is equal to positive 4. So that is the p-value of the coordinate of the solution. So we found p. Let's find q now. So take the p, put it into one of these equations, and solve for q. I'm going to pick 3p plus 4q equals 4. So we'll do 3 times 4 plus 4q. We're going to set that equal to 4. So then 3 times 4, that's 12 plus 4q. That's going to equal 4, which means 4q is going to equal negative 8, which means q equals negative 2. So the q value of the coordinate of our solution is negative 2. So now going in true alphabetical order fashion, the ordered pair that's the solution is going to be 4, negative 2. That would be the solution to this system of equations, would be 4, negative 2. Again, heck, you could use substitution if you want to. You really could. But do you really want a bunch of fractions and punish yourself? That's why I say substitution is not always the best method for every system. Alright, so what do we got here? We got 4r plus 9s equals 23, and negative 7r plus 3s equals negative 24. So in this system we have 4r plus 9s equals 23. Then we got negative 7r plus 3s equals negative 24. Well, I think it's safe to say we want to multiply the second equation by 3 and therefore get the same coefficient of s. So we could temporarily get rid of s. So let's take 3 times the second equation. Now, first equation still stands. You'll have 4r plus 9s is equal to 23. Now 3 times negative 7r, that's going to be negative 21r, plus 3 times 3s, that'd be plus 9s. That's going to be equal to 3 times negative 24, which would be negative 72. Well, what we have to do now is we need to what I'm going to suggest here is, since you have both 9s's, positive 9s's on the s term, you subtract the second equation from the first. So if we do that, you'll get 4r minus 21r, which turns into 4r plus 21r. That's going to give you 25r. Then you have 9s minus 9s, that's 0. But then you have 23 minus 72. That turns into 23 plus 72, which would end up being 95. So 25r equals 95. Well, we need to take r. That would be 95 divided by 25. But they both have a common factor of 5, do they not? So what I'm going to suggest here is we simplify this. 95 divided by 5, that's going to be 19. And then 25 divided by 5 is 5. So the r value for your solution is 19/5. Yes, you will get fractions sometimes. Now, you're going to want to put this r value into one of these equations, solve for s. So we'll do 4r plus 9s equals 23. Let's come over here. So you'll have 4r plus, whoops, r has the value. What am I thinking here? So we'll have 4 times 19 fifths plus 9s equal to 23. Well, 4 times 19, that's going to be 76. So you would get 76 fifths plus 9s. Well, we need to figure out what 23 is in terms of a fraction of 5. That'd be 115 fifths. This is going to make your life a lot easier when you go to solve this, all right? So you'll have 76 fifths plus 9s equals 115 fifths, which means 9s is equal to 115 fifths minus 76 fifths, which would be 39 fifths. Well, 9s equals 39 fifths, so that means s equals 39, and then you would have 1/9 times 5, so you'd have 39 fifths times 1/9. That would give you 39 over 45. But both of these have a common factor of 3. If you divide out a 3 from both the numerator and denominator, you'll get s equals 13 fifteenths. So the s coordinate of your solution is 13 fifteenths, the r coordinate is 19 fifths. So your ordered pair, that's the solution, is going to be 19 fifths, 13 fifteenths. And that would be your answer to this, would be 19 fifths, 13 fifteenths. That would be your solution to this system of equations. Yeah, you can get ugly fractions sometimes. That does sometimes happen. Alright, what do we got next? 4b plus 13c equals negative 24. Then we got 12b minus 5c is going to be equal to positive 16. So in this system of equations, we have 4b plus 13c equals negative 24, then 12b minus 5b equals 16. I think it's fairly obvious we can multiply the first equation by 3 and get a 12b, so then we can temporarily eliminate the b variables. So let's go ahead and do just that. We'll multiply that first equation by 3. So if we do 3 times 4b, you get 12b. Plus 3 times 13c, that would be 39c. That'd be equal to 3 times negative 24, that's negative 72. And then you still have your 12b minus 5c is equal to 16. Well, you have the same coefficient now on the b's, so we can subtract the second equation from the first. So let's go ahead and do that here. 12b minus 12b, that's 0. 39c minus 5c, that turns into 39c plus 5c. That would give you 44c. That's going to be equal to negative 72 minus 16. Well, that'd be negative 88. So now you have 44c equals negative 88. That means c equals negative 2. So the c coordinate of the solution is going to be negative 2. Now all that's left is to find the b coordinate of the solution by putting your c value into one of the equations. I'm going to go with 12b minus 5c equals 16. So we'll have 12b minus 5 times negative 2 equals 16, which means you'll get 12b minus 5 times minus 2, that's actually plus 10. That'd be equal to 16, which means you get 12b equals 6, which means b equals 6/12 or 1/2. So the b coordinate of the solution is going to be 1/2. So this goes in alphabetical order. Your ordered pair that's a solution is therefore 1/2 negative 2. So the ordered pair that's a solution for this equation is going to be 1/2 negative 2. Alright, we are down to the final 5. We got the final 5. Let's see. 18a minus 5b equals 17. 6a plus 10b equals negative 6. So we got this system of equations here. We have 18a minus 5b equals 17. Then we have 6a plus 10b equals negative 6. Well, two options. We can multiply the second equation by 3, and then the second equation will have a variable with a coefficient of 18, then we could temporarily eliminate a. Or we could multiply the first equation by 2, then we'll have a negative 10b in the first equation, we can temporarily eliminate b. I'm going to suggest we go the route of multiplying the first equation by 2. It really doesn't matter, just why work with a bigger number if you don't have to? So 2 times 18a, that's going to be 36a, minus 2 times 5b, that'd be minus 10b. That'd be equal to 2 times 17, which is 34. Then you still have your 6a plus 10b equals negative 6. Well, you notice now you have a negative 10b in the first equation, a positive 10b in the second. I think we could just add the two equations together and we can temporarily eliminate b. So 36a plus 6a, that's 42a. Then negative 10b plus 10b is 0. That's going to be equal to 34 minus 6. That'd be 28. So we have 42a equals 28 rather. So that means a equals 28 40-seconds, which both 28 and 42 have a common factor of 14. If we factor those out, you would get a equals 2/3. So the a coordinate of the solution is going to be 2/3. Now that we've solved for a, let's solve for b by putting the a value into one of the equations. I'm going to go with 6a plus 10b equals negative 6. So you'll do 6 times 2/3 plus 10b equals negative 6. Well, 6 times 2/3, that's going to be 4. You would get 4 plus 10b equals negative 6, which means 10b equals negative 10, which means b equals negative 1. So the b value for the coordinate of the solution is going to be negative 1. So that means the ordered pair that is your solution for this equation is going to be 2/3 -1. That would be the ordered pair that would be your solution to all this is 2/3 -1. I got 4 more. Alright, what's next? 3p plus 8q equals 8. So 3p plus 8q equals 8. And then we got 5p minus 2q is equal to 21. Alright, so we have this system of equations, 3p plus 8q equals 8, and then 5p minus 2q equals 21. I think in this case it's obvious we want to turn that negative 2q into a negative 8q. So you'll multiply the second equation by 4, and then both q's will have the same coefficient. So let's multiply that second equation by 4. If we do well, we'll still have 3p plus 8q equals 8. Then 4 times 5p, that's going to be 20p. Minus 4 times 2q, that'll give you minus 8q. That's going to be equal to 4 times 21, which we know to be 84. So now you have 3p plus 8q equals 8, and then 20p minus 8q equals 84. Well, you have a positive 8q in one, a negative 8q in the other. We can add this together and temporarily eliminate the q variable. Add both of these together. So 3p plus 20p, that's 23p. Then you have 8q minus 8q, which is 0. That's going to be equal to 8 plus 84, that's 92. So 23p equals 92, that means p equals 4. So the p coordinate of the solution is going to be 4. Now all we need to do is find the q solution. In order to do that, we need to put the p value into one of those equations and solve for q. I'll pick 3p plus 8q equals 8. So we'll do 3 times 4 plus 8q equals 8, which means 12 plus 8q equals 8, which means 8q would equal negative 4. So q would equal negative 4 over 8, or q would equal negative 1/2. So the q coordinate of the solution is negative 1/2. So we got p being 4, q negative 1/2. So the ordered pair that's your solution is going to be 4, negative 1/2. That would be the solution to this system of equations, 4, negative 1/2. All right, 3 more. We have 4x plus 15t equals 10. Then we have 3x plus 10t equals 5. Okay. We've hit a bit of a conundrum here. There's really no apparent way that's preferred to solve this. I mean, we're going to do the same process, but what I'm trying to say is it's not as simple anymore as just multiplying one of the equations and adding or subtracting. You have 4x, and then you have a 3x. You have 15t, and then you have a 10t. So, what you can do, if you want to make the x variables the same, you can multiply the first equation by 3 and then the second equation by 4. In fact, let's do that. So the first equation we're going to multiply by 3. The second equation we're going to multiply by 4. So if we do that, 3 times 4x, that's going to give you 12x, plus 3 times 15t, that would give you 45t. That'll be equal to 3 times 10, which would simply be 30. Now then we have 4 times 3x, which is also 12x, plus 4 times 10t, that's going to be 40t. That would equal 4 times 5, which is 20. So now, since we've multiplied both equations, you get 12x plus 45t equals 30, and then 12x plus 40t equals 20. Well, both x variables have the same coefficient, so you can subtract the second equation from the first one. So let's go ahead and do just that here. 12x minus 12x is 0. 45t minus 40t, that just gives you 5t. That'll be equal to 30 minus 20, which would give you 10. So 5t equals 10 means t equals 2. So we have the value of t being 2. We want to find the x value now. So what I'm going to suggest here is, well, actually what we need to do, not even a suggestion, you put the t value into one of these equations and solve for them. I'm going to pick, now you see the multiplication, ignore that multiplication. Only put the t value into the original equations there in the black. So I'm going to solve for x. I'm going to go with 3x plus 10 times that t value of 2, set that equal to 5, all right? Which would give me 3x plus 20 equals 5, which means 3x equals negative 15, which means that x would equal negative 5. So the x value for my solution is negative 5. But we have to go in alphabetical order. T comes first. So you'll get the ordered pair 2, negative 5 as the ordered pair of your solution. You'll get 2, negative 5. And I only got 2 more problems, then we're done for the day. All right. We have 6n plus 8c equals 4. Then we have 9n plus 10c equals 7. So 6n plus 8c equals 4. 9n plus 10c equals 7. Well, again, this isn't one where you're simply just going to multiply one equation and then have the same coefficient. You could figure out the least common multiple of your coefficients. Like, for example, let's go with 6 and 9. What's the least common multiple of 6 and 9? That's going to be 18, right? So your least common multiple of 6 and 9 is 18. What you can do then to make your dreams come true, to make the n coefficient 18, take your first equation, multiply it by 3. Take your second equation, multiply it by 2. I mean, if all else fails, you can simply multiply 6 and 9. You could get a 54n for both of your constants, but why in the world would you want to do that and work with bigger numbers? It's easier just to find your least common multiple, so you get smaller numbers to work with. So we've multiplied the first equation by 2, so 3 times 6n, that'll give you 18n, plus 3 times 8c, that would give you 24c. That would be equal to 3 times 4, which is 12. Then you have 2 times 9n, that's 18n, plus 2 times 10c, well, that'd be 20c. That's going to be equal to 2 times 7, which would be 14. So now you have 18n plus 24c equals 12. Then you have 18n plus 20c equals 14. Alright, well, we see the n coefficient's the same, so we can subtract the second equation from the first and therefore get a result for c. 18n minus 18n, that's 0. 24c minus 20c, that's just simply 4c. That would equal 12 minus 14. That'll give you negative 2. So we got 4c equals negative 2. So now c would equal negative 2/4 or simply negative 1/2. So the c coordinate of the solution is going to be negative 1/2. So we found c. Let's go ahead and go for n. Stick it into one of your original equations. I'm personally going to go with 6n plus 8c equals 4. I like it because they're smaller numbers. So we'll do 6n. Remember, when you've had to multiply both equations, disregard the multiplication you did. Only go with the original equation. That's why I'm using different colors here, because I want it to be easier to see. So you'll have 6n plus 8 times negative 1/2 would be equal to 4. Well, you'll have 6n. Now 8 times negative 1/2, that's negative 4. So you'll have 6n minus 4 equals 4, which means 6n would equal 8. Well, n would equal 8 divided by 6, or simply 4/3. So the n coordinate of the solution is going to be 4/3. So going in alphabetical order, list your c coordinate first. You'll have the ordered pair negative 1/2, 4/3. So negative 1/2, 4/3 is the ordered pair that is your solution to this system of equations. We got one more problem, then we are done for the night. And that's truly it. Alright, 6z minus 5t equals negative 10. We got 6z minus 5t equals negative 10. 4z minus 7t equals negative 25. Alright, so we have this system of equations here. 4z minus 5t equals negative 10. And then we have 4z minus 7t equals negative 25. Let's start with t. If you want to find the least common multiple of 7 and 5, you would have to, it's going to be 35. You'd have to multiply the first equation by 7 and the second equation by 5. And then you would get your wish of having both t's being 35. You could eliminate the t. But to me, that seems like an awful lot of work. You're going to get a lot of bigger numbers for the other values that you just don't need. Why don't we look at 6z and 4z? Look at those coefficients. What's the least common multiple of 4 and 6? That's going to be 12. I think what we should do is temporarily try to eliminate z by multiplying the first equation by 2 to turn that z coefficient into a 12. Then multiplying the second equation by 3 to turn that z coefficient into a 12. So if we do this, 2 times 6z, that'll actually give you 12z. Minus 2 times 5t, that'd be minus 10t. That's going to equal 2 times negative 10, which would simply give you negative 20. Then you have 3 times 4z, that's also a 12z, minus 3 times 7t, that's going to be minus 21t. That's going to be equal to 3 times negative 25. Well, that would give you negative 75. Well, what do you know? Both equations, you have the same coefficient on the z variable of 12. That means you can subtract the second equation from the first. So let's go ahead and do just that here. You'll have 12z minus 12z, that's 0. Now you'll have negative 10t minus 21t. That means that's negative 10t plus 21t. Well, that'll simply give you 11t. So you'll have 11t is equal to negative 20 minus 75. That means you'll have negative 20 plus 75, which would give you 55. So you got 11t equals 55. That means the t value for your coordinate is going to be 5. So we've solved for t. Now we simply need to solve for z. That's going to be done by putting the t value into one of these equations and solving for z. I'm going to go with 6z minus 5t equals negative 10. So I'll take 6z, yeah, we'll do it in black, why not? 6z minus 5 times 5 is going to be equal to negative 10. That means you'll have 6z minus 25 equal to negative 10, which means you would get 6z equals 15. Well, 6z equals 15, z would equal 15 divided by 6, which they both have a common factor of 3. That would give you 5 halves. So the z value of the coordinate's 5 halves. So we go in alphabetical order. Your ordered pair that's the solution is 5 halves. And that would be your answer for the solution to this system of equations, would be 5 halves. So that's it, at least for now, for solving systems of equations. Next lesson, we're going to solve some simple inequalities. It'll probably even seem like a review of pre-algebra a little bit, but solving inequalities are necessary because eventually it's going to lead into solving systems of inequalities, which are almost done graphically, but it's still good to know how to solve systems of equations when you go for systems of inequalities. So I hope everybody has a good night. Take care.